this is the first film of a set of films about basic sensing elements. And the first group of elements here are the resistive sensing elements. So before we go through the different sensing elements, we have to know a bit about resistance and resistivity. Any conductor, for example this one here, let's say that this is a conductor, a section of a conductor, it will have a resistance R. And you know from the Ohm's law that V equals R times I. So the resistance is what links current and voltage. The higher the resistance, the lesser the current, and so on. The resistance on its side depends on three things. The Greek letter rho, and L for length, and A for cross-sectional area. So the area is measured here, and the length is measured here. The rho on the other side is the resistivity of the material. So some materials have higher resistivity than others. In other words, how good they conduct current. For example, gold has a low resistivity, while for example carbon has a high resistivity. And things like plastic, they have an extremely high resistivity, which means that they carry current very poorly. So the higher the resistivity, the higher the resistance. Then the length. The longer the conductor, the higher the resistance. And finally, the area. The wider the conductor, the lower the resistance becomes, because you have more material that you can run the current through. So therefore, the resistance overall depends on those three elements: the material it's made of, the length of the material, and the cross-sectional area of the material.